Oh, we're gonna get started in 5 minutes. 5 minutes. Let's do the pre-show.
one, fire!
It's time. Yes, the countdown has ended. The rocket has launched. I can't believe we're here. It's the end of the year. It's the shortest day of the year. And it's the end of year spectacular. Oh my gosh, we just hit 100 viewers. Oh my gosh, 100 live viewers. Hi everybody. Happy holidays. Happy almost end of 2020. I'm so glad to see you all here. Thank you so much for coming out to hang out with me over the next hour. We got lots of fun stuff to talk about. We're going to talk about the best space stories of the year. We're going to obviously talk about the great conjunction that's happening behind all those clouds that are in the way of most of us in Southern Ontario being able to see it. And we're going to also open up the floor near the end to do an Ask Me Anything. So you can ask anything you want. It can be about space. It can be some fun stuff. I'll probably answer most of it. So. But first off, this is the end of the year, and this is kind of a thank you stream to everybody who has supported Astronomy in Action for the year. It's been a weird year for everybody, right? And things started out really, really well. Like we were doing lots and lots of live planetarium shows, going to a lot of schools. We had a whole March break lined up, and then the pandemic happened, and everything got canceled. I remember the last show I did on Friday the 13th of March, the day before March break started. And I was on the phone constantly over my lunch break talking to people because they had to cancel shows because of the lockdown starting. And a ton more shows got canceled over the next couple months, and it was just kind of radio silence for a while. I did a couple of live programs, but just this planetarium live thing that some of you might have seen a little bit earlier. And a little bit earlier on in the year. And that was really fun, but it was really a couple people who got me started doing the live stream programs that kind of kept me going and kept the company going throughout the fall. So first of all, a big thank you to Andrea Belanda. I don't know if she's on right now, but she was the one who had a booking and said, hey, let's just do it as a live stream, and you should totally do this because I bet people would really enjoy seeing you do live streams. And I thought, well, it's not the planetarium, but we made the most of it, and thank you to everybody who ended up booking the live streams in the fall. I did so many of them, and it was so much fun. And it's just nice to be able to do that thing that I love to do and talk about space with you. And then the second person I have to thank is Elizabeth Vos, the Thrifty Crafter, who booked a group of lovely homeschoolers who you're watching now, who enjoyed the program so much they wanted more, and so we ended up doing a 4-week-long split program on the night sky, the planets, the galaxy, and the universe, and going deep into a lot of things. And I got to know a lot of those kids really well, and the parents, and so thank you very much for all of that. Hey, Andrea is here. Amazing. Some people can't see me. Oh no, that's terrible. If you can't see me, just try and refresh the stream. That might be part of the issue. Anyway, so those are a couple of people that I really wanted to thank for helping out. And of course, thank you for just coming out and hanging out, spending some time learning about space. I could talk about how grateful I am all night, but we're here to see some really fun space stuff and celebrate the end of a crazy year and hopefully moving into a better next year. So thanks everybody for being here. Let's talk space. And of course, we have to start with the great conjunction that unfortunately we can't see. I know it's tough, but we can at least go into the programs and take a look and see it on Stellarium and see it, investigate a little bit, see what we have here. So this is right now, and of course the sun has gone down, the planets have set, but there they are, Jupiter, Saturn. The letters are all merging together. There we go. Let's go and zoom in and see how close they actually are to one another. Very, very close right now. If you had a telescope that could see the two of them, they would appear in the same field of view. Very, very close together. It's called a great conjunction because it's two of the main planets of our solar system, the 2 of the 5 visible planets in the sky that are right next together. Hey, Violet, nice to see you. Thanks a lot, everybody, by the way, for saying hellos in the chat. I am going to answer questions in the chat if I see any, because there's a lot of us chatting here tonight, so there's a lot of people who are checking this out, which is really fun. And I also have to say, this is like the only time I've ever been nervous for a show, because I'm so excited to talk to all of you and give you some love from all the love that you gave me over the past year. So let's continue. So yeah, Jupiter and Saturn very, very close together. Now, did anybody happen to see them over the past week? I mean, we had a couple clear nights in the past week, which was really great. We could go outside and see all of this stuff. You could see the 2 planets. They're naked eye visible, which means you don't need binoculars or a telescope or anything to go and see them. And you know, if you did see them last night, oh geez, I lost them again. Let's go select one. That'll help a little bit. Last night, Saturn was there. A couple nights ago, I think it was clear, Saturn was there. A couple nights before, it was there. So even though they're very close together in the sky, a lot of people talk about it as a Christmas star, right? They see it as one star or as one object in the sky. They're so close together. But believe it or not, when they are in the sky together, seeing them, we would be able to tell that they were 2 separate objects. A good kind of similar object to look at is if we go and take a look at the Big Dipper. In the Big Dipper, there are 2 stars, second from the end of the handle, called Alcor and Mizar. And they're a double star, a pair of stars that orbit one another, and they're very close together as well. Well, if you go outside and take a look at the Big Dipper, you can see those 2 stars, and you can actually see that there is a separation between them. And so that's kind of a good analogy for how close Jupiter and Saturn are. And you can go outside, of course, and see the Big Dipper any night of the year, as long as it's clear. Okay. Nathan says we saw it 3 days ago. That's great. That's amazing. So, I mean, over the next few days, too, it's still going to be visible. It's just they're not going to be right next to each other as we can see them now. I mean, we can go and take a look. Oh, yeah, and you can watch them come close together. The Yeetmeister, what a great name. Watch them coming together all summer, every clear night, right? Tomorrow, it's not going to be that different. It's actually going to be just fine tomorrow. If we get a clear night tomorrow, or the next night, or on Christmas Day, Christmas Eve night would be nice too. They're still going to be really close together, and it's really cool to see these planets just after sunset. Now, of course, they are really, really far apart, right? When we see them, we talk about them being close together. It's really the angle between the 2 of them. Right? So if we pop over to Space Engine, I know I've shown some people this before, but if we take a look at the orbits in our solar system. Hey, 55th Toronto Sparks, say hi. Nice to see you, Sparks. Thanks for hanging out. I'm so glad some of you could organize some watch parties and actually spend some time with me so close to the holidays. We don't need galaxies. We'll come back to those. But okay, so we have the Earth right here, but look at where Jupiter and Saturn are. There's Jupiter with all of its moons whipping around it, and Saturn over there. So they're still really far apart, right? Several 100 million kilometers apart from one another. But they form a nice line from the Earth to Jupiter to Saturn. And that's what makes the Great Conjunction. That's what makes it so that we can see these 2 planets right next to each other in the sky. That's the difference. Right? They're still really far apart. Saturn is much more distant than Jupiter, but these great conjunctions happen because the 2 planets appear on a straight line from Earth. Now, I took a look at the previous great conjunctions, right? And because there's been a little bit of confusion. I've heard from some people who will say, oh, it was 400 years ago. And others will say, oh, the last one we could see was 800 years ago. Hey, 14th Niagara Falls Brownies, thanks for tuning in. This is so nice to see so many Girl Guides of Canada groups joining as well. I have to say, Girl Guides of Canada has been a huge supporter of the programs, and we've been doing programs across the country this year, which is kind of the benefit of the live stream. You know, we can't really take the planetarium across the country, at least not yet, but it's nice to be able to talk to groups from all across Canada. So, okay, so I wanted to go back and take a look at the conjunctions, the great conjunctions that happened. And so the cool thing about Stellarium is that we can actually do this. So we're going to set the date to the last one, which was the year 1623, July, so 7. No, just 7, please. Okay, fine, we'll do it the hard way. And it was July 16th. 16th I wrote down, so there we go. So that, now we're in July, it's July 16th, and this was just after sunset. So we actually, now I looked at this one a little bit earlier. The planets are very close together, but they're so close to the sun that in the 1623, nobody could really see this because Jupiter and Saturn were so close to the sun that right after sunset, the planets couldn't be there. So they couldn't be seen. But they did get very close together, as you can see, the two planets, just as close as they are tonight. The moon's, of course, in a different spot. But we also had planets like Uranus there. Look at that. Right close to them. And Mercury and Venus. That would have been a sight to behold, because Mercury and Venus you can see with just your eyes, of course, right? So if we let the sun go down, unfortunately, Jupiter and Saturn back in 1623, nobody really got to see it. But they did get to see Venus up in the sky. Who else do we have? Oh, some other guides. 55th Guides. Hi, 55th Guides. Simran. And we have some Brampton Guides, the 63rd. Amazing. This is great. It's so nice. Hey, and Lucan, the Lucan Guides and Pathfinders are tuned in as well. Good friends who I hope to see again soon. Pretty cool. This is great. See, you know, I'm just really enjoying all the love. I got to try and stay focused on the things that I'm doing, but it's just so nice to talk to all of you again at the end of the year. Is that Kenneth? Yeah. Has there ever been all of the planets in a line? Yes, the planets do kind of line up. I mean, if we look at the solar system, you know, you can let time go. Like if we just set time to go forward and let time go really, really quickly, you know, eventually all the planets will just line up. It happens not too often, but every few hundred years or 1,000 years, you could probably get all of them to line up. And we could probably just do that. I mean, we could even look at the inner planets and say, hey, let's just wait until they all line up. And, okay, it's going to be tough, but I'll be here for a while. But eventually, you know, all the planets do line up, and it really doesn't mean anything fancy. It's just that they all line up as viewed from Earth. The gravitational force of the planets doesn't change at all. It doesn't change our feeling on Earth, anything like that. Oh, Joaquin, 5 years old, asks, how big is the solar system? Oh boy, it's big. It's so big that if you traveled on a beam of light, it would take you a whole day to get across the solar system. Now, a beam of light travels so quickly that you could travel all the way around the Earth 8 times in just 1 second. What'd I do? Turn off the orbits there. Okay, so imagine traveling on a beam of light. You go all the way around the Earth 8 times in just 1 second. Super, super fast. Earth is huge, over 30,000 kilometers around. And so imagine traveling that fast 8 times around the Earth in 1 second. To get to the moon would take you 1 second. To get to Mars would take about 3.5 minutes. To get to the sun would take 8 minutes. But to go all the way across the solar system, about 10 billion kilometers would take an entire day, even for a little beam of light. And yet, as big as our solar system is, the galaxy's a lot bigger. That's a great question. Thank you. It is really huge. Okay, so we looked at the first of the great conjunctions, or at least the most recent one. The most recent one that people could see was in the year 1226, and that was March 5th. March 5th. This one was interesting because it was actually in the morning before sunrise. So we actually have to go backwards in time. So all the way back. Try not to... Whoop, did I go too far? Nope, it was in the morning, so we got to keep going. Let the sun go all the way across. Come on, sun. There it goes. And there. So this was the last great conjunction that people could actually see in the sky. And this one, they were really close. Like, imagine seeing that in a telescope. Jupiter and Saturn, like literally right next door to each other, high-fiving each other. And for anybody who saw the Google Doodle today, that was kind of cute, eh? They like literally high-fived each other as they went by. Pretty awesome. So that was the last conjunction, the year 1226, March 5th, that human beings could actually have witnessed. The other one was too close to the sun, right, in the 1600s. Now, for those who are interested in the next one that we can see is going to be in the year 2040, which is not too bad. It's not going to be as good as these ones that we've seen, but so the year 2040, November 5th, November 2nd. And that's not bad, because on November 2nd of 2040, they're pretty close together. Not as close as they are tonight, but we'll have Mercury, we'll have the moon. It'll be a very nice little scene. So there's something to plan for in the year 2040. We'll set an alarm for that one. Okay, Simran wants to know how many planets are there and have we found them all? Simran, there are a lot of planets out there. A lot. If we go back to today, if we go back to right now, we just look at the stars in the sky, here's all the planets. All those green dots are stars where we found planets. And this is going to be a good lead-in into some of our top stories of the year. So we talked a little bit about the conjunction. Yes, the Great Conjunction, right? That happened tonight that we're not going to get to see, but that's okay. Come back tomorrow, see it again. See the planets close to each other. Okay. So we're gonna talk about the top 2020 stories in outer space. Now, I do a radio show on Monday nights every so often, usually like once a month, called York Universe, and that's the York University Observatory puts on this show through an online radio station called Astronomy.fm. And so I get to do that with some professors, some students. It's a lot of fun. And what we talked about the last show of the year, about a week and a half ago, was some of the top stories in 2020 of space. And so I kind of poached that list a little bit to talk about some of these stories. But I picked ones that I thought were really interesting across a wide variety of stories about space flight and human beings and asteroids, and some really interesting discoveries about planets and stars and things like that. So I'm going to go through some of those stories and talk about them a little bit. If you want to ask some questions, please do. I'll try and keep an eye on the chat and see what we're looking at. And then I'm going to try and do most of the non-topical questions at the very end, because we're going to just do an Ask Me Anything after all of this. Yeah, the space posters, they're great. They're I actually was talking to a family about them recently. They're absolutely free. Just look up NASA tourism posters, and you can find them. They're totally free. So you can print. That's what I did. I just printed them off in slightly larger size so that they look pretty nice. You know. Okay, so let's talk about some of the big stories of this year. Now, the first one I want to talk about was the launch of human beings aboard a commercial shuttle, spacecraft, and that is, of course, the Dragon Crew Dragon capsule. So this is Bob and Doug earlier this year. It was May. What day in May was it? May 3rd was the first launch, and these two guys launched inside this capsule. Instead of being cramped inside a little Russian Soyuz capsule, these two astronauts fit in this much more futuristic, comfortable capsule and launched up to the International Space Station. And I remember this well because it was really neat to be able to see the space station in the sky. I remember the night that the launch happened, I went out to the park by my house and looked up, and you could see the space station, and you could see this little ship following it, this little light, and that was these guys inside this capsule. And so we're going to watch the launch. There were two of them this year. This was the first one. This was kind of a test. The astronauts just spent a few days up in space and then came back to Earth. The real launch, the one where it's like, okay, we're actually launching a crew, happened this past month. So we got to see 4 astronauts launch up to the International Space Station inside a crew Dragon. Pretty awesome. And so the launch is really cool. It's really neat to see these because they're reusable rockets. The capsule at the top goes up to the International Space Station. The rocket itself, the Falcon 9, comes right back to Earth. Pretty amazing. So we're gonna watch the launch because it was kind of neat. And this is a big step because first of all, it's commercial companies launching people up to space, which has never happened before. This partnership between NASA and SpaceX. It's also the first time astronauts have been launched from American soil since the last space shuttle launch. And it's now an easier way to get astronauts up to the International Space Station. And because it's reusable rockets, this is really exciting, is that with reusable rockets, suddenly it becomes cheaper to do everything in space. It costs less money to send people. It costs less money to send cargo. It costs less money to do anything in space. And that's the ultimate goal for doing more and seeing more and going farther. That's this rocket. They made it up traveling at 27,000 kilometers an hour to catch up to the International Space Station. Yeah, that's so they are kind of upside down while going up in the rocket ship. That's one of the things you kind of have to get used to. But once they get up into orbit, they don't really feel anything. And I saw a question earlier about, why don't we feel the Earth turning as we spin? And it's basically it all has to do with acceleration. If you accelerate, it's kind of like if you're in a car, the car speeds up, you feel yourself push back against the seat. If the car slows down, brakes, you feel yourself pushed forward. Push forward. And so it's acceleration that we feel. And because the Earth is spinning at a constant speed, we don't really feel that acceleration. The air around the Earth is also moving at that speed. There you go. So yeah, this was the launch, and they went up to the space station. This is the booster heading back down to Earth, which is pretty cool. And this goes all the way down, and we'll see if we can watch it land. It's pretty neat stuff. I mean, human space flight is just such an interesting thing and such a difficult thing to do. Outer space is cold, it's empty, it's dark. But the whole point of the International Space Station, which one of the other stories of this year is that it passed its 20th year of operation. That other amazing thing is that the space station is letting us learn how to survive in space. Oh, Evelyn wants to know, why is there fire on the rocket? Well, a rocket, Evelyn, is basically a big explosion. And that's what propels the rocket up into space. That's what makes the rocket go forward. It's not like a car with an engine. It's like this big rocket literally has to blow up to push itself up into outer space to keep going really, really quickly. Oh yeah, okay, so it's on its way down. It's going to pass through the clouds. I think the booster actually didn't make it. I can't remember. But there you go. So that was, and there they are inside the capsule. Looks a lot more comfortable than the Soyuz. Looks a lot more comfortable than the Soyuz. Awesome. Okay, so that was the first one. The big story that I really want to talk about, that I'm really excited to talk about, is Comet NEOWISE. How many of you saw the comet that just appeared in the sky in June and July of this year? It just came out of nowhere. It was, and comets often do. Comets are these big dirty snowballs in outer space, most often 4 or 5 kilometers wide. The way I like to describe them is if you get some of the snow that you find in March or April, where it's like slushy and it's covered in sand, and you make that into a snowball, it's dirty and it's slimy and it's grimy. That's what a comet is, just a lot bigger than that, 4 kilometers wide. And so Comet NEOWISE, so a couple people saw it. It was barely visible to the unaided eye, but it was a really neat thing. And so we're actually going to go and visit that comet because it's fun to talk about. I always love bouncing back in time in this program, so we can do it. So that was 2020, and we'll go to July. And we'll go find Comet NEOWISE. And it's okay if you didn't see it. I mean, comets, I can count in my lifetime about 5 or 6 major comets that have happened. So here's the comet itself. It looks, dirty snowball kind of thing. But as comets get closer to the sun's light and warmth heats them up, and they start to release some of the ice, some of the gases that are trapped, and the dirt, and all that stuff comes off. I blinded Oren. That's a kind of a running joke. All the dust and things come off, and we end up with these two tails. Comets have two tails. They have a dust tail and an ion gas tail. And the idea is that because dust is a little bit heavier, the dust tail trails off a little bit based on the direction that the comet is moving. Whereas the gas tail, the blue one, disappears straight away from the sun. So you can see the sun there, it's blown straight away, but the comet is also moving around the sun, and so that's why the dust tail changes a little bit. So there you go. And whoops, there it goes. I went a little too fast. But we watched the comet. Let's go backwards in time a little bit. Oh, I went too fast. If you haven't seen my shows before, I find a way to mess up something every time, but that's okay. Let's go at current time, normal time speed, and see if we speed it up a little bit. You can actually see the comet as it works its way around the sun. The blue tail, the ionic tail, always points away from the sun. The dust tail kind of trails behind where the comet's moving. Who names the comets? Typically, a comet is named after the first two people to discover it. So there's a bunch of comets named Shoemaker-Levy because they were discovered by, I can't remember their first names. I know David Levy, but he was a Canadian astronomer. But Shoemaker, I can't remember his first name. But it's usually the first two people to observe it. And often comets are discovered by amateur astronomers with telescopes looking up to the sky. So watch this. As the comet goes around the sun, notice that the comet's actually traveling to the left of the screen. The tail doesn't always point away from the way the comet is traveling. It usually points away from the sun because the sun's light, the sun's energy is blowing it away. Okay. So let's go a little faster. If we pull up the orbits, you'll kind of see the orbit of this comet. As we go around the plane of the solar system, you can see where all the green lines there are all the planets. The light blue are dwarf planets. So this comet gradually makes its way around. This comet takes 6,700 years to go around the sun, and it does orbit the sun. And as it starts to move out away from the sun, the tail gets smaller as there's less radiation from the sun pushing on it. The tails line up a little bit. You still see the dust coming off of it. There we go. And eventually the tail slowly disappears. We're into August now, and it by August it was pretty much gone. To September. And the comet's still there. It's still a big snowball of dirt and dust and gas. But it just doesn't have the big tail anymore. So that was a huge thing. And comets are really unpredictable. Really, really unpredictable. Like you can have a comet that you think is going to be amazing, that's going to be beautiful and bright and visible and the comet of the century, and then it just doesn't do anything. A story I think I've told before is there was a comet called Ison. When I was working at the Ontario Science Centre, we were really excited about Comet Ison because it was going to be like this, oh my gosh, it's going to be the greatest thing ever. If it goes around the sun and survives, it could be the brightest comet of the century. And we watched it all year and tracked it, and then it went close to the sun and it never came out the other side. It never came out the other side. So that comet got so close to the sun that the sun just shredded it completely. And that happens to a lot of comets that get close by. So there you go. So that was kind of fun. All right, so that was the comet story. My gosh, we're already half an hour in. I did tell some people that I would do this for about an hour, but I mean I'll probably stick around and do the Q&A far after that. So yeah, don't even worry about that. A really big story was OSIRIS-REx. It was a space mission that launched in about 2014, I want to say, maybe 15. And it went to an asteroid. And this year it landed on this asteroid. Evelyn's dad's asking if all comets have ice on them. All comets do have ice. That's kind of what helps define them as comets, between their really crazy orbits and the fact that they're kind of snowy and icy. So the OSIRIS-REx, the spacecraft, goes to this asteroid, and this is a real footage of this spacecraft landing on the asteroid called Bennu. It's still there. It's still there. And it took a sample of this asteroid that it's going to bring back to Earth. So it's going to return to Earth September 24th, 2023. And we can actually go and see Bennu. Where is Bennu? B-E-N-N-U. An asteroid. And so, you know, most asteroids are a little bit different than comets. We talked about the ice in comets. Well, asteroids can be watery, but they typically have slightly different orbits, or a little bit more rocky. And there you go. So here's Bennu. I'm going to lower the brightness a little bit. So it's kind of a weird potato-shaped asteroid. How big is it? Diameter, okay, so about 500 meters, about half a kilometer wide. And so OSIRIS-REx is actually on this asteroid right now, took a sample of it, and is going to return it to Earth. Now, why do we do that? What's the point? Why send a spacecraft here to do that? The reason is that these comets and asteroids, especially, are things that have been around since the beginning of the solar system. Now, I've shown this video to some of you before, but I'm going to show it again because it's fun. It's basically just how the sun and the solar system formed. It's just the titles in French. There's no audio, but basically when you have a solar system forming, it starts out as this big cloud, this nebula, this clump of gas and dust that starts to shrink down. And as it shrinks down, it gets flat like a frisbee and it spins really quickly. In the center, you end up with about 99% of everything. And that's where the sun is born, in the very center. But all that leftover stuff can form things like planets and moons and comets and asteroids and dwarf planets. And that's what happens in most cases with stars, is that they should have planets and they should have moons or asteroids or smaller rocks orbiting them. And so when we talk about an asteroid like Bennu, Bennu has been around since the beginning of the solar system. 4.5 billion years. A very long time. When we look at rocks, or like planets, for example, you see these collisions are happening. The planets get really warm, they heat up, those rocks melt down, and they become part of the planets, they get recycled a lot. The rocks in asteroids have been the same for 4.5 billion years. So it's kind of like a time capsule for the beginning of our solar system. So we can look back, we can look at these rocks, we get these samples of these asteroids, and we can see exactly what it was like when the solar system was born. So bringing this back to Earth lets us use some of the most powerful instruments we have on planet Earth of figuring out what conditions were like in that time, studying these rocks. It's the same as bringing back a part of the moon with the Apollo missions. Except even the moon isn't as old as some of these asteroids and comets that are up in outer space. So that's the OSIRIS-REx sample return mission, right? Sample return mission. So there's another one that actually happened too. It was called Hayabusa. Hayabusa, you might have heard of it just because it was this month. A Japanese team from the Japanese Aeronautics, what's JAXA? I can't remember the acronym. But basically brought back a sample of another asteroid called Ryugu, this one. And I love this little like animation. I'm sorry it's so small. But basically this tiny little asteroid as well, another sample was brought back from it all the way to Earth. And that sample arrived safely on Earth. And it's especially amazing because this is the culmination of years and years and years of a scientist's life to build a mission, to go to this asteroid, to grab a piece of this asteroid and bring it back to Earth. Bring it back to Earth. Okay, so I'm seeing a lot of great questions in the chat. I'm going to try and answer them a little bit later because I do want to make sure for those who are watching that we get to cover all the things that I wanted to talk about, the big stories of the year. And then, like I said, we'll do a free-for-all in the questions kind of at the end, okay? So if you want to just hold on to your questions, I'm happy to answer all of them just a little bit later, okay? So we got about 25 minutes until the top of the hour, and I still want to show a lot of really fun stories that happened this year, and then we'll move on a little bit more, okay? Plus, I also I do love questions, and I want to make sure that we get a chance to answer all of them. So yeah, so let's keep going. Okay, what other stories happened this year? Well, there was a big story about the planet Venus, because you've probably heard that there might have been life on Venus. In fact, there might still be life on the planet Venus. And a group of scientists in October, it might have been a bit earlier than that actually, September, announced that on Venus they had found a very special molecule called phosphine. And actually it looks pretty good here, but I'm going to bring it up in Sandbox because it's much more fun. We can actually strip down the atmosphere of Venus in Sandbox. So let's bring up Venus. There it is. So Venus has really thick atmosphere, really thick clouds. It's about the same size as Earth, the second planet from the sun. And if we actually, we can get rid of the atmosphere and see that beneath the clouds, Venus is really not a very nice looking place. It's very warm. The pressure's really high. It's right 400 degrees on a normal day. It's got active volcanoes on it. So it's really not a great place for life, right? But a long time ago, astronomer Carl Sagan had theorized that maybe in the atmosphere, up in the clouds of Venus, higher up in the clouds where the temperature was a little bit better, 30 degrees, 20 degrees, a little bit more comfortable, that maybe there were clouds of bacteria high up in Venus. How thick are the clouds? I'm not sure, to be honest, but very, very dense. And they're made of carbon dioxide, which we know is a greenhouse gas on Earth. So Venus is effectively a runaway greenhouse effect, where there's so much carbon dioxide, all the rays from the sun get trapped. The infrared light from the sun gets trapped underneath the clouds and heats them up and heats them up and heats them up. And so that can happen to Earth, but only if the carbon dioxide keeps increasing in our atmosphere. So in the clouds of Venus, it was thought that if you go high up enough, you could have life there. Maybe there's big clouds of bacteria that are living and getting energy from the sun inside these big clouds. And it was also thought that maybe someday human beings could go and build floating cities. Yeah, it's like global warming. It absolutely is global warming in a way, right? So it'd be kind of cool to have cloud cities up high in Venus. Imagine living in big bubble cities high up in the clouds where it's not super hot and not super cold, right? Because you don't have outer space. So anyway, this team of astronomers found this chemical called phosphine, which, as far as we know, phosphine can only be formed by living organisms, or at least the vast majority of it can be. It can be produced a little bit in volcanoes, which we know Venus has, but these astronomers, based on the amount of this molecule that they saw, the amount of phosphine that they saw, it was about, I think, 100 times as much as... about 100 times as much phosphine as any natural source could produce. And so they thought, well, the only way that could be is if there's life there that's causing this. How do they find it? I'm trying to remember what telescope they used. Let me see. I'll pull up the article because I'm kind of curious now. Okay, it was in September. There you go. What did they? Oh, Atacama. Okay, so. Yeah, ALMA, which is the Atacama Large Millimeter Submillimeter Array. So radio telescopes. Oh, hey, right on. Hi. I'm from Ms. Delonge's grade 5-6 class. Hey, nice to see you. Thanks for coming out to watch. So they use this telescope to look for phosphine. They found it But you probably haven't heard much about it since, because what happened was the very next month, a lot of astronomers raised some concerns about the data. A lot of astronomers were talking about, okay, well, I don't know, this doesn't necessarily make sense. The signal could be quite not real. It could be changing the data a little bit and giving you this false result. And so the astronomers took another look at the data. They went through it again, and they realized that there was a signal error that affected the results. And so basically what happened was they made this claim. They said, hey, we think we found all this phosphine on Venus, and that would be amazing because it could mean that there's life there. But then a lot of astronomers raised concerns about that. They said, well, hey, let's double check all this stuff. Let's make sure that's right. The astronomers who released the original data double checked all their stuff, all their science, their signal, all that stuff. And they basically found that they had made some mistakes, that the amount that was actually there wasn't as much as they thought. It was still some, and it's still up in the air. But it wasn't this earth-shattering thing where it's like, hey, there must be life on Venus. And so expectations are a little bit tempered now, and the team is still working on their data to see kind of what the actual results are. So we're still waiting on that. But that's an important part. It's an important part about science, is that most scientific work, most professional scientists, when they release data, when they release results, they're doing it with a lot of work behind it. If you're going to make an extraordinary claim, it means it requires extraordinary evidence. And so this team thought that, well, hey, we're making this claim, we have all this evidence, we have the signal, we have the results. Please try and prove us wrong. And that's what good scientists do. They put out this data, they put out their results, they put out their ideas, and they say, let's do the science. Let's figure out if it's right. And if it's wrong, we need to figure this out. We need to figure this out. Okay. So we really need to figure this out, right? And that's kind of the good thing about science, is that it gives us a way to find the truth. You know, you can produce some scientific results, but if they're not reproducible, if they're not testable, if they're not confirmable, then it doesn't matter. Oh, hey, Julie, how's it going? From the Guelph 27th Guelph Girl Guides. Nice to see you. Thanks for coming out. So that's Venus, and there still could be life on Venus. There still could be those bacteria way up high in the clouds. But we don't know. So maybe we need to send another spacecraft there to take a look. So that was a really huge story, really huge story. The next one, now you might have actually seen this. The Arecibo radio telescope collapsed, which is a really sad day for astronomers, because this was a wonderful giant 300-meter radio dish that was looking for signals from life in the universe. It was a big it was used for SETI, and it collapsed, and they caught drone footage of it. So look at this. These are massive cables, steel cables. Oh, hey, Jen. Hey, Lucas. Where's the moon? Oh, buddy. I'm surprised you haven't seen enough of the moon by now. Whoa, yeah, so look at that. Well, we'll try and take a look at the moon. Yeah, so Arecibo, actually, massive amount of damage. There was some damage to it. It didn't have the funding to get fixed. And then this collapse happened. Earlier this month. Really, really sad. This instrument was so important to so many astronomers. It made some amazing discoveries. It's still there, but it probably won't be fixed anytime soon. Here's the first view of it. I mean, it's an interesting looking video, but yeah, this is, you know, at the end of its life, it didn't have the funding to keep it going. And it's way more expensive to build a new telescope, right? So I was really sad to see that happen. There you go. Okay, now one more. Well, two more, actually. Oh, yeah, I forgot about this one. Okay. We had a new record for the longest duration mission. Longest duration space flight by a woman astronaut, Christina Koch. She was in space for 328 days. 328 days. That's like 10 months. Longest space flight ever. Broke the previous record by Peggy Whitson. She did several spacewalks outside the International Space Station and lived there in zero G or microgravity. 328 days in space. Really, really amazing. Simone wants to know, why was Arecibo destroyed? It actually was breaking down, and it didn't get a lot of funding for repairs. Unfortunately, it's something that big. It takes a lot of money to maintain it and keep it in working condition. And because it's very old, at least 30 years old, it's really hard to repair something like this. And so what happened was it ran out of repair. They knew it was dangerous. They knew it was going to potentially fall apart. They didn't know when. Engineers were on site looking at it, trying to do an assessment of how long it had and if it could get some emergency funding, if we could repair it. But that's when that drone that we saw here, that's when the drone was up looking at it and saw the cable broke, the telescope broke, and now it's a lot more money to get it fixed. So that's kind of why it was destroyed, Simone. It wasn't intended to be destroyed, but it's an expensive, massive piece of scientific equipment that takes a lot of money to maintain and keep nice, so there you go. So yeah, going back to Christina Koch, how did she stay at space for 328 days? Well, she did it on the International Space Station, right? The International Space Station. Let's go take a look, because we can. The ISS. You're welcome, Simone. Thanks for the question. So here we go. The ISS flying around the Earth right now. She lived on board this spaceship 328 days. That is almost a year. I think only about 4 or 5 astronauts have ever spent more time than that in space, which is an incredible feat. And it's not easy to be in space, right? I'm sure I've talked about this before with some of you, but your muscles get weaker, your bones get brittle. We'll let it go into the daytime side so that we get to. Let's go all the way to daytime. Hey, some aurora in the background. That's kind of nice. Your muscles get weaker, your bones get weaker. It is psychologically difficult too, and it just is a testament to her strength, mentally and physically, to be able to do that kind of thing. Spacewalks are no walk in the park. I know it's kind of a funny way to say it. Spacewalks are very difficult as well. To put on the big spacesuit, to go outside of the space station where it's cold and dark and empty, and you're inside this spacesuit for hours and hours and hours. It's really a challenge. Here we go. We're getting back to daytime. Make it look a little bit brighter. Oh, gotten a hiccup there. That happens. We're doing pretty well though. So and this space station going around the Earth at 27,000 kilometers per hour, every hour and a half, it goes all the way around. So there's no day and night up there. There's a sunrise and a sunset every 45 minutes apart. It's really tough to be in space for that long. Most astronauts do 6-month terms in outer space and then come back to Earth, just because it is so physically demanding. It's so hard on their bodies and their minds. But not only did she spend 328 days in space, she did spacewalks, she did science experiments, she talked to people on the ground and did outreach, and was just a very good ambassador for spaceflight, for the astronaut program. and she contributed a lot to human knowledge of outer space. So major kudos to her. And then the last one I wanted to talk about, I think I posted about this recently too, was the Gaia spacecraft. Now Gaia is a spacecraft that does what's called astrometry. So it measures stars, and it's looking at over 1 billion stars in the sky, in our part of the Milky Way galaxy. And what it does is it measures their position and their speed, how they're moving, where they are. And just using that, it can make up this kind of map where we can travel over 1 million years in the future and see how stars will move throughout the galaxy. This is one of the, and I wanted to bring this up because this is a really important part of science, is that a good scientific theory and good scientific work can allow you to make predictions about the future. It's like fortune telling, but real. It actually works. And so this is a map of where stars in our night sky are going to end up over the next 1.6 million years. 1.6 million years. Pretty amazing. All right. What are the black things on the map? Just the darker spots, maybe. Some of the gas and dust along the core of the galaxy, that kind of thing. So pretty amazing. And just knowing that, it gives us a much better idea of what is happening in the Milky Way galaxy. It gives us a better idea of the structure of the Milky Way. By studying just 1 billion stars. It's 1 billion stars, which is still like 1% or a quarter of a percentage of the whole galaxy. What happened? Oh, I had galaxies turned off, I think. There we go. That's better. So, like, just by understanding that, it teaches us a little bit more about our place in the Milky Way. Those 1 billion stars make up just a tiny circle around where the sun is in the Milky Way. There's still so much that we haven't seen and haven't learned. But the Gaia mission is still going strong and will go for another 4 years at least, where it's going to take more information about the stars and tell us more about our Milky Way and about how things are happening. Okay. So it was kind of a... Oops. Oh, that was weird. Oh, okay. So it's been kind of a mishmash of stories, I know. Kind of all over the place, but it's fun. It's nice to reflect back on the year that, although it's been really crazy, there was a lot of good science that was done. There were still a lot of fun things to look at. Some of these things I looked at and I couldn't believe. I was like, oh my gosh, is it actually this year? Did it actually happen this year? Because this year was kind of crazy and long and yet very short. I don't know. So with that said, we've talked about a lot of really fun stories. We talked about the Great Conjunction. And now I'm just going to open it up. It's 5 to 8. I'm going to keep talking for a while still, but thanks a lot for everybody for tuning in so far. I'm going to answer questions. I'm going to open up the floor to any questions you want to ask. It can be about space. It can be stuff for me. I'm happy to answer anything that you want at all. So let's see what we've got. If we can't travel very far in space, then how do we know how much the temperature or weight of a faraway planet like Saturn is? Well, for Saturn, what's great is that we've actually been to Saturn with spacecraft called Cassini, and Cassini could measure, it had what's called an accelerometer on it, so we could measure the difference in the gravity of Saturn as it moved closer or farther from the planet to be able to figure that out. The harder thing is how do we, weigh stars? How do we weigh planets around other stars? And really, the answer isn't that exciting. It's math. it's by using some mathematical techniques, we can look at how things move around each other. We have a good understanding of gravity, and we can say, oh, well, if we know that how these two are moving, we have a pretty good idea of how heavy they are. Okay. Thanks, Kenneth. Nice to see you, my friend. We'll see you next time. Okay, what would happen if Jupiter collides with... Oh, Kenneth, that's your question. What would happen if Jupiter collides with Saturn? Why not? Let's do it. I love this kind of thing. It's fun. Let's make Jupiter collide with Saturn. Jupiter and Saturn. Okay, there's Jupiter. There's Saturn. Now, I've said this before, but usually the biggest thing wins. The most massive thing wins. The heaviest thing wins. So if we let time go, who's going to win? Oh, it's getting crazy, but it looks like Jupiter's going to win that battle. Didn't they hear a heartbeat from a cloud of gas earlier this year? Not that I know of. You couldn't hear a heartbeat from a cloud of gas because they don't really have a heart. But there are sounds that you can generate based on images. So what I think you might be thinking of is I'm going to try and pull it up as we watch Saturn and Jupiter spiral away from each other. Let's see if we can focus in on them on Jupiter and see it slowly tear Saturn apart. There's things that you can do techniques with so images, and we're going to look up sound. Yeah, so it's called sonification. Sonification. So I'll see if I can show you what I mean. So what it'll do, it's not really like a heartbeat per se, but what it'll do is it'll look at a distant galaxy. So like if we bring this up, here's your sonification. So it's some distant galaxies, this big picture, and based on the amount of the brightness that's there, you can use it to produce sound waves. And just create sound patterns from the light that you see. So it's called sonification. It's a fun way to get kind of imagined data, right? How many moons does Jupiter have? Jupiter has 79 moons. 79 moons and counting. Maybe Jupiter will have more someday, but who knows? Oops. There we go. So that's kind of the cheesy way to crash Jupiter and Saturn together. I'm sure we can do this a bit better. Oops, what did I do here? Oh, one sec. I'm just going to try and fix my sandbox thing. There we go. That's better. How do astronauts eat? Well, they put the food into their mouth and then they chew. No, I know. I'm sorry. That's a mean answer to the question. Astronaut food is usually freeze-dried, which means it's not very nice to eat. It's packaged together. It's not very palatable, but they use hot water to heat up their food in the packages, mix it all up, and then eat it. So some of the best things that astronauts get to have are fresh fruits and vegetables. And they get fresh fruits and vegetables really just whenever there's a new mission that comes up. So some of the nice there you go. So Jupiter wins, right? The biggest thing wins. So one of the nice things for astronauts is whenever new astronauts come up, they'll bring fresh fruits and vegetables. When all you eat is packaged food, all you want is something fresh and delicious. You can't have a microwave on the space station, although I think they're working on one. You can't really have an oven because heat moves in a very interesting way in microgravity. So they have to be really careful about the way they eat things. They can't have bread because bread makes crumbs, and crumbs can get into machines and computers and ruin instruments, that kind of thing. So it's not a good thing. So when they eat, they do have kind of a limited supply of food. They have a limited type of food that they can have. It's tough, and that's one of the hardest things about living in space. And there you go. That's for Lucas. There's the moon. I said we look at it. How do stars get created? Stars form when those clouds of dust and gas collapse. So we saw that video about the sun getting formed, right? So this cloud of dust and gas, usually a molecular cloud, starts to collapse under its own gravity, and it starts to spin and flatten out like a frisbee. And in the very center, that's where most of the stuff ends up. And in the very core of that clump of stuff that's getting higher pressure and higher temperature, two little atoms of hydrogen smash into each other again and again and again and again and again, 1 billion times a second. until finally they fuse together and make a brand new atom of helium. And when they do that, they release a huge amount of energy that starts a chain reaction called fusion, the fusion reaction. And then that's just this chain reaction of more atoms smashing into each other and releasing energy, and then you get a star. That's how stars are born. They're giant nuclear bombs exploding all the time. Pretty cool. As we watch our moon work its way around. So that's how stars are formed. Are there any black holes in our galaxy? We think there's about 80 to 100 million black holes in our galaxy. The problem with black holes is that we can't see them, right? Like if I can bring up a black hole here in Universe Sandbox. So here's a black hole. Wow, look at that. It's dark. But what happens though if we go far away from it? You know, aside from the fact that the label's there, like if we get rid of the label. Okay, there we go. Where's the black hole? It's still there, but I can't see it. It doesn't give off any light, right? Oh, Helen, thank you so much for coming out. Yeah, I mean this is fun. I'm to be honest, I'm more kind of relaxed with this one. I was nervous when we started, but then I thought, you know what, we're just having fun exploring things. Honestly, I could probably do a whole hour of just questions for all the people who want to watch and see that. So thank you. What are the clouds on Venus made of? Carbon dioxide, mostly. Also some sulfuric acid, which it does rain acid on Venus, but most of the rain doesn't get very far down in the atmosphere before it evaporates and goes back up and does it again. But just going back to my black hole point here, the black hole's there, but we can't see it. The only way you can really see them is if you can look and say, hey, maybe a star passes behind or in front of the black hole and the light gets bent a little bit. And then you can see that. It's called a microlensing event. And there's been surveys to look for these microlensing events, but they're just so hard to find. They're just so hard to find. So there's a lot of, there's thought to be about 100 million black holes in our Milky Way galaxy that we just can't see. But luckily, they're pretty small, though. Most of them, like this one is 100 times as heavy as the sun. But look, it's only 300 kilometers wide, which is really, really tiny. So only if you got very close to it would something bad happen. So one of these black holes could probably pass right through our solar system. Maybe not one this big, but a smaller one. And we probably wouldn't notice it that much. Is the crater from the asteroid that killed the dinosaurs still visible? Sort of. It's in Mexico. It's part of the Yucatan Peninsula called Chicxulub. Actually, you know what? I'll bring it up. I'll see if I can bring up a map to show you. So we'll look at the Yucatan Peninsula. All right, we're going to do something new. We're going to bring up a map. Holy moly. There's the map. So this is, you can see the Gulf of Mexico, the Caribbean. The Yucatan Peninsula is right here. And actually, the crater itself is pretty big. It's like, I think it's like 60 kilometers across. Let me see what the scale is. Yeah, so maybe 100. So this is what you actually see. And I was watching a documentary on this the other day, is that in Mexico, on this peninsula, there's a half ring of what are called cenotes. Cenotes are basically little freshwater sinkholes. And those cenotes all appear along an arc right about here. There's lots and lots of cenotes in this peninsula, but a ring of them, a half ring, goes like this. And so we think that the other half of the crater is in the ocean, or in the Gulf of Mexico. And so this was the crater left over from 65 million years ago that we think led to the extinction of the dinosaurs. Goodbye, Settlers Green PS person. Thanks for coming out. Thanks for hanging out. It's nice to see you. We still have 119 people viewing. I'm blown away. I'm used to doing like programs for not very many people. 30 people at a time, 20 people at a time. I really appreciate it. Can you drink water in space? Absolutely. If you didn't drink water in space, you wouldn't last very long. Human beings can't last more than 3 days without water. Andrea Belanda says, my husband is a pilot and has seen Elon Musk's Starlink system many times flying at night. How is that affecting astronomy and the viewing of the sky at night? It's definitely a concern. It's one of those things where, you know, you look at outer space and we say, okay, the more stuff that's up there, the more it can obscure our view. The challenge is, you know, you've got amateur astronomers, people with telescopes who want to look up and observe something. And if you're trying to take a photo of something, a long exposure photo of something, it's really tough to have these satellites whizzing by because it can ruin your photo. Now, that's not a huge concern. I mean, okay, so some people's photos get ruined. But for research grade telescopes, that's a big deal. For telescopes that need to train on an object for hours and hours and days and keep taking more and more data, if those satellites are whizzing by, it can actually ruin the scientific value of having that telescope. And so if you're going to spend $100 million on a giant telescope to have it ruined by satellites, that's a bad thing. And so I know that as far as Starlink goes, there's been some talks to put less reflective coatings on the satellites to prevent them from being seen as easily. But I mean, that's just Starlink, and that's something like 1,000 objects, 1,000 satellites up in space. So, you know, every extra 1,000 satellites you add takes up more space. It means more tracks in the sky. And a good way to kind of visualize how that will look is if we go to Stellarium, we can actually go a little bit earlier in the evenings. And the best time to see satellites is early in the evening, by the way, if you want to. But if we let time go, you should be able to see some satellites whizzing by. And I'm going to slow it down a little bit. Because if we just kind of go up. Now, of course, they're going to fail me completely. Maybe a little bit later. Yeah, it's kind of hard to see, but you'll see some satellites whizzing by. Usually right around sunset. There you go. See, there's a bunch of them. A couple of them whizzing by there. Ooh, there goes another one. There goes another one. Right? So now imagine that times 1,000. You've got Starlink satellites. You've got lots of different things. Why does the light get bent when it passes a black hole? Because the black hole literally bends space and time. The beam of light thinks it's traveling straight, but the space-time itself is curved around the black hole. And so the light beam that thinks it's traveling straight actually goes straight and gets bent around the black hole. That's kind of why that happens. Okay. So that kind of, I hope, gives you some insight, Andrea, into the satellites. It's still a little bit tough. And I think it's always going to be a challenge as more commercial enterprises want to put things into space. It will become a bigger problem. And so it's important that astronomers and scientists speak to these commercial ventures, speak to governments, and we're all part of the conversation so that we can ensure visible night skies for future generations. Because I know that without being able to look at the night sky, I wouldn't have been an astronomer for sure, right? Like it's this connection that you get from looking up into space. T. Wright says, is this a website that you were looking at? This is called Stellarium. Absolutely free program. I use it every day because it's amazing. You can use it to look at things in the sky, and I often plan out observing nights as well by using Stellarium. So you can go to stellarium.org. There's a web app. You can get it for free. I think the cell phone app is like $4, $5, but I love the program. As you can see, I do lots of lessons and things with it. While we're here, let's go look at the moon for Lucas's sake, my young friend. Let's see. Ben Meager says, if the same two people discover a comet 3 times, how would they keep track of them? That's a really neat question. They actually, they'll name them Shoemaker-Levy 1, Shoemaker-Levy 2, Shoemaker-Levy 3. There's actually a bunch of them. And in fact, one of those comets actually crashed into the planet Jupiter in 1994, Shoemaker-Levy 9. This comet came very close to the planet Jupiter. Jupiter's gravity, as it does, shredded that comet into tiny chunks, and those chunks smashed into the clouds of Jupiter. And actually was a really interesting scientific event because astronomers who were watching this happen really gained some good insights about the density, about the composition of Jupiter's lower atmosphere underneath the clouds. Alexis, what if the moon crashed into the Earth? Well, let's do that. I love requests. What if the moon crashed into the Earth? What is the app's name? Is Stellarium. This one that I'm using now is called Universe Sandbox. Universe Sandbox. Oops. There we go. There's the Earth. And we're going to launch the moon at the Earth to see what happens. Launch. All right. Let's get a good view before we do this and slow it down a little bit. Oop, there we go. Cool. So that's what would happen. Earth gets really warm. It's not very comfortable. The app is also called Stellarium. So you can find that there. Is the storm on Jupiter ever going to end? Probably not, unfortunately. Unfortunately, I mean, it doesn't really affect us in any way. Jupiter is a self-sustaining planet. Like it spins so quickly that in just 9 hours, and that's kind of why we see big storms appear. It's just because Jupiter is so large and it spins so quickly. It's a gas planet. It spins in just 9 hours. Yet it's 1,000 times larger than the Earth. These moving clouds create these rapid spinning currents, and the red spot doesn't seem to be going anywhere. An earlier question I saw from Liz, our thrifty crafter: have we ever confirmed the existence of rogue planets? Now, rogue planets, for those who have never heard of that before, rogue planets would be planets that are just off in space between stars. I don't know if they've been confirmed to exist, but they should. They absolutely should. We've seen very crazy events happen where stars interact, planets interact, and can send objects flying out of the solar system. The question is, though, at what point, like how fast does a planet need to be ejected from its star before it can't come back? And turns out that's actually quite a high speed. So it can, as far as we know, it can happen. I don't know if any rogue planets have been discovered, but now I'm kind of curious and I want to find out. So it's very likely that there should be rogue planets. And the really crazy thing is that what if there are rogue planets out past our galaxy, right? Like what if we look at the Milky Way and out past the Milky Way, there are planets in between other galaxies. Maybe there's rogue planets way out here. We know that there are rogue stars in between galaxies. Why not rogue planets? Pretty crazy. Alexa says, thank you, made my family happy. I'm really glad. We do this for fun, right? I'll probably be doing this again in the new year anyway. Is it Uranus or Neptune spinning downwards because it got hit by an asteroid? It's absolutely the planet Uranus spins sideways. It got hit by an asteroid a very long time ago, or probably a small planet early on in the solar system, and that turned it on its side. So if we go and look at Uranus, if we see how Uranus spins, see how it's spinning sideways? And I've talked about this before, but this is kind of cool that, as Uranus orbits the sun, it takes 84 Earth years to completely orbit the sun. And so half the time is daytime and half is nighttime, just because of it spinning like this. So 42 years of daylight, 42 years of darkness. Evelyn asks, is Pluto a planet? Pluto is what we call a dwarf planet right now. It used to be a planet. It was discovered in the year 1930. But in 2006, astronomers had found so many more things beyond Neptune that they decided that, okay, well, we need to come up with a new definition. And I'll just kind of give you an example. I know I show this often, but if we go and look at the solar system orbits, why am I moving forward? I don't know why that's happening. Let's try that again. I might have just hit a button. There we go. Okay. So if we bring up the orbits and the labels. So for a long time, after Pluto was discovered, we didn't know that there was anything else out past Neptune. But today we know of a lot of stuff. All those dots, those are all rocks, comets, asteroids, lots of them. We have 5 dwarf planets in our solar system, 5 dwarf planets. Pluto, Eris, Ceres, Haumea, and Makemake. What a great name. So today, out past Neptune, there's all these other rocks. We know that Pluto's not alone. It's part of this belt called the Kuiper Belt. And so in 2006, that was when the decision was made to say, well, now we need a new class of things. We can't just have asteroids and comets. We can't just have planets and not planets. We need something kind of in between. Something that goes around the sun, orbits the sun, something that is round like a planet, but is too big to be an asteroid. And that's where we get dwarf planets from. Aaron Onadera has a question for me. How was the universe made? Holy smokes, Aaron, you're asking the tough questions, kiddo. The universe started 13.8 billion years ago in a giant explosion that we know as the Big Bang. And one of the ways that we know that is that when we look at galaxies in outer space, this is a picture of real galaxies. Every dot in this image is a galaxy. A guy named Edwin Hubble, who they named the telescope after, a very long time ago, 1920s, he looked at all of these galaxies and he discovered that every single one of them was moving away from us. Every one of these galaxies is moving away from us, away from the Milky Way. And not just that, they're moving away from each other too. The only way that could happen is if all of them are moving away from everything else and space itself is growing. Which means, Aaron, if you and I sat across from each other for long enough, the space between us would get bigger and we would be farther apart. Space itself is growing very slowly for you and I, but across the universe, it happens really, really quickly. And that also means that a long time ago, 13.8 billion years, all of the galaxies, all the stuff, the entire universe was at the same spot, in the same point. Goodbye, Rasco stuff. Thanks for hanging out. And that when everything was at the same point, that's what we called the Big Bang a very long time ago. 13.8 billion years. So that's how the universe was born, in this Big Bang. And as it continued to expand, the universe is still expanding today, but we started to see galaxies form, and within those galaxies, stars and planets and moons and asteroids, and eventually human beings. Andrea Curtis, thank you for joining. It's so nice to see you from the Guelph Public Library, an excellent human being. Always great to see me in action. Yeah, totally. Have a Merry Christmas and a Happy New Year. You as well, Andrea. Thanks for coming in, tuning in, and for the support. I hope to be back at the library next year once we can do that safely, Awesome. Can you make all the planets crash together? I know a couple people were asking about that. Let's do it. Are all planets and dwarf planets named after Greek and Roman mythology? They are. Typically, when we look at our night sky, is the combination of 3 cultures. So here, sorry, I'm kind of looking around my camera here. The combination of 3 cultures. So let's just go back. We're still looking at the moon apparently. There we go. Okay. So 3 cultures. So the planets are Latin or Roman. They're named after Roman gods. The constellations are Greek. Excuse me. Constellations are Greek, and the names of the stars are Arabic. So we have 3 different cultures who have contributed to the modern sky and the naming convention that we use today. So that's kind of the idea behind it. The planets, mostly Roman mythology, the constellations Greek, and the stars Arabic. Thank you, Stephanie and Nathan, for spending some time. It was nice to see you. Okay, we're going to crash everything together. Because why not, right? Okay, we've got... There's planet Uranus. Let's put all the planets together. Now, okay, who do you think's going to win? I think you know the answer to that. There's Jupiter. We'll put them kind of in order. We'll put a new Uranus there. We'll put Saturn in. Put Uranus in there in front a little bit. We'll put in the rocky planets, Mars and Earth and Venus and Mercury. Okay, who's gonna win? Jupiter's gonna win. We know the answer already. And we end up with basically a big hot Jupiter. Funny story, hot Jupiter is the name of a type of planet that we typically find around other stars. They're very big, they're very, very close to their star. And we call them hot Jupiters for that reason. So let me show you a hot Jupiter. And these were, you put the sun in, okay, well the sun would win for sure. Hot Jupiters, there's going to be some brightness. A hot Jupiter, if you had a star, would be a planet that is very, very close to its star in orbit. Jupiter's probably a bad choice for that. Let's say Neptune. So very, very close. Okay, that was too close. And it got destroyed. Okay, so I should have paused it. But but essentially the planet orbits really, really close to its star. And the reason that we know it's there is because its gravity is pulling on its star. So that's how we discover those planets. Okay. Yeah, that was fun. Sirius Black from Harry Potter is named after the planet Sirius. So that's the star Sirius, the star Sirius. So you're on the right track, though. We can actually see Sirius, the star, not the person, not the character, in the sky. Is it upright yet? I don't think so. It's over here. There's Leo. Oh, yeah, it is. Okay, so there you go. It's in Canis Major, the big dog, so it's often called the dog star. And if you remember Harry Potter, what did Sirius turn into? Turned into a dog. So look at that. This is the constellation of the big dog, Canis Major, the brightest star in the night sky, Sirius. There you go. We're losing some people to attrition. We've been talking for 1 hour and 25 minutes. I'm going to go 5 more minutes, okay? So I'm going to answer a few more questions. I did want to answer that one question that was really early on from... Who was it? It was a very advanced question. I was actually really impressed with it. I just couldn't answer it at the time. I think it was from Krista. And she was asking it quite a bit, and I did want to come back, circle around, and answer it. Would we be able to shift the rotation of a supermassive star undergoing a supernova explosion so that the resulting gamma ray burst from the black hole would destroy a specific star system? Kind of sounds like you're making a Death Star, right? Kind of sounds like you're making a Death Star. I'm fairly certain that that's not possible at our current level of engineering. But, I mean, who knows? There's a lot of things we could accomplish. I would like to hope that if we could accomplish a feat like that, diverting gamma ray bursts from a giant exploded star towards something else, that we would do it for purposes of generating energy and not for destroying stuff. Kat, you're very welcome. Thanks for hanging out. It was nice to see everybody. And nice that all of you could see me. So that was good. Andrea says, thanks, Ryan. All the best to you over the holidays and looking forward to our guide meeting on the 6th. You bet, Andrea. I will be in fine form. We'll have a lot of fun. Thanks for the awesome presentation. I hope you can present at my school next year when COVID-19 is over. I hope so too. I hope so too. Thanks a lot. I don't see too many more questions. I think we're good. Let's call it here. Thanks a lot, everybody, for tuning in. This was a lot of fun. I mean, honestly, I could just sit and answer questions for 2 hours, and that would be like the best show ever, right? Wouldn't it be? Wouldn't that be fun? Again, thank you, everybody, for all your support. I really appreciate it. Clara wants to know about the 13th zodiac sign. Clara, it's called Ophiuchus, and Ophiuchus is in the sky. You can see it right now toward the east. Here it is. It is the snake charmer. That would be the 13th zodiac sign, the snake charmer. Hey, I just joined, so you can tell me a little bit about the Christmas star. There's not too much to tell, my friend. It's basically what we call a conjunction of Jupiter and Saturn that are so close together that we could see the two looking like one object in the sky. It happened just after sunset, so let's back up a little bit. And you can kind of see, as we drop down a little bit, there's Jupiter and Saturn, very close together. There you go. That's the Great Conjunction. That's your Christmas star. If there's an end of space, what happens at the end? More space, I guess. I think, Smile and Style, what happens, we think, is that if you... Maybe the universe is curved like a ball, so that, how on Earth, when you walk in a straight line, if you walked for long enough, you go all the way around the Earth, Happy holidays to you, right? Thank you very much. Thanks, Julie, for checking it out. If you could walk all the way around the Earth in a straight line, eventually you'd come back to where you started. Maybe the universe is like that too. Maybe if you travel in a straight line for long enough, you'll come back to where you started. But I have to say, it's hard to get to the edge of space because space is actually growing faster than anything can travel. So really tough to get there. Hey, Megan Gilchrist is here. Thanks so much for this presentation. Our unit really enjoyed it. Hope to have you back in 2021. Definitely. Always nice to see some good friends, talk to some real astronomy enthusiasts. We'll see you next time. My daughter Mila wants to know, how far is Neptune from Earth? Neptune's your favorite planet? I liked Neptune a lot when I was a kid because it's blue, and blue is my favorite color. And so why don't we go and investigate Neptune? Let's do it. I've always got time for my friends. Okay, Mila, let's see Neptune. Just for you. There's our big, beautiful blue Neptune. Let's see. I don't know if it gives the distance in here, but I know it will in Space Engine, so maybe I'll go there. Neptune. Okay, 31. Okay, so Neptune, it says... Oh, no, that's how far away I am. So it's... semi-major axis is 30... Okay, so 30... So Neptune is 30 astronomical units away from the sun, which means 30 times 150 million. So that would be 4.5 billion kilometers from the sun and just a little bit less than that from the Earth. So usually, for Mila, Neptune is about 4 billion kilometers from the Earth. There you go. How far is Jupiter from Earth? Jupiter's a lot closer. Let's see Jupiter. This is good. I love we're still going. Jupiter is 5 astronomical units, so about 750 million kilometers from the sun. Hey, Merry Christmas, Leanne and the Ray family from Cookstown, my hometown. Thanks, Violet. See you in the new year. What is space expanding into? That is the million-dollar question. Tropical Mango Dragon. I love your name, by the way. That's it. Okay, I think we're going to call it. For everybody who's left, 74 viewers still, thank you so much for tuning in. Honestly, from the bottom of my heart, to be able to do this is just the most wonderful thing in the universe. I'm really lucky that I get to talk to all of you about space, and I don't take that for granted. So thank you so much. I hope everybody has an amazing holiday. a great end to 2020, and I'm wishing all of you my very best for a happy, safe, healthy, prosperous 2021. I guess we'll see you then. Thanks, everybody. See you next year. Oh, I love you all. This is wonderful. Happy holidays, everybody. See you, Madison.